Welcome to a video about radioactivity and nuclear chemistry.
Radioactivity is a phenomenon in which certain elements spontaneously emit radiation resulting in changes in the nuclei of the element.
There are three types of radiation: alpha, beta, and gamma.
Alpha radiation is when an element splits into two elements, releasing a hydrogen atom in another element.
Beta radiation is when a beta particle is released from the nucleus of the atom. If the particle is negatively charged, it will raise the atomic number by 1, and if it's positively charged, it will lower the atomic number by 1.
And gamma radiation is when an unstable atomic nucleus dissipates energy by gamma emissions, producing gamma rays. Now we go to something about nuclear chemists. Here we go.
Paul Villard, a French chemist and physicist, discovered gamma radiation in 1900 while studying radiation emitted from radium. Villard's radiation was named gamma rays by Ernest Rutherford in 1903.
Radioactivity was discovered by Becquerel, something French, in 1896. Within a few years it was discovered that there are actually three kinds of radiation and radioactivity, which are given the exciting names alpha radiation, beta radiation, and gamma radiation.
Rutherford worked out that alpha radiation is actually the nuclei of helium. By allowing alpha radiation to go through the thin walls of an evacuated glass tube, and later analyzing the gas in the tube spectroscopically.
What are half-lives? Half-life is the amount of time required for a quantity to fall to half its value as measured at the beginning of a time period. Basically, it is the length of time it takes something to die halfway.
Differences between fission and fusion. The main differences between the two processes is that fission is the splitting of an atom into two or more smaller atoms, while fusion is the combining of two or more smaller atoms into a large one.
This is how a nuclear reactor works. At nuclear power plants like Chernobyl, the heat to make steam is created when the uranium atom splits, called fission. There is no combustion in the nuclear reactor. Here's how the process works. Pressurized water reactors, also known as PWRs, keep water under pressure so that it heats but does not boil.
What is the chemistry behind nuclear weapons? Fission of hydrogen or uranium or plutonium causes the massive explosions that are released by nuclear weapons.
You wouldn't know how these work. You were the only one to use atomic bombs on civilian populations.
Yeah, it's coming from you that made Chernobyl blow up.
We didn't make Chernobyl blow up. We had nothing to do with it. It was not Mother Russia. This is how nuclear chemistry is involved in medicine. Nuclear chemistry in medicine uses focused radiation to decay cancer cells. Radiation therapy uses high energy radiation to shrink tumor, kill cancer cells. X-rays are also another type of radiation that allows you to see through the body. You know what an X-ray is? Remember the little goggles? Yeah, all that. Radiation may be delivered by a machine outside of the body, or it may come from radioactive material placed in the body near cancer cells. For example, they use radioactive iodine and inject it near the cancer cells, and it may have a chance of killing it. Half of all cancer patients receive some type of radiation therapy.
Well, now we're at the end of the video and we must explain our hero.
Nathaniel Christopher Adam, aka Captain Adam, was a former United States Air Force officer in the Vietnam era. He survived an explosion from an atomic bomb that the US government had set under the hull of a crashed alien ship. The explosion threw the captain 40 years into the future and melted the hull of the alien ship to his body, giving him his metallic look and indestructible containment suit. Flaws in this: he survived the superatomic bomb. The heat vaporizes you instantly. There's no surviving that. There's no turning into energy. No, you just vaporize. His radioactive containment suit does not give off any radiation. He does not have a half-life. He is literally pure radioactive energy, but does not obey any of the laws of radiation.
Well, it's the end of the video. Thanks for watching.
Goodbye.